The topic for my thesis is ERA-AODV for minutes to improve reliability in energy efficient way. To start with, we'll give a brief introduction to minutes. Mobile ad hoc networks. Mobile ad hoc networks is basically a collection of independent nodes that can communicate with one another through radio waves. The mobile nodes that are in radio range of each other can directly communicate, whereas the other which are not in the direct radio range of one another have to take the help of intermediate nodes. These networks are fully independent and distributed and can work at any place without the help of any fixed infrastructure such as base stations. In this figure, we can see a network formed by three nodes. Node 1 and 2 are in direct communication range of one another, so can communicate directly, but if node 1 wants to communicate with node 3, then it has to make use of an intermediate node, that is node 2, to transfer its messages to 3. Minute characteristics. Distributed operation. There is no background network for the central control of the network operations, so the control of all the network operations is distributed among the nodes of the network itself. Multi-hop routing. Node which wants to send information to some another node which is not in a communication range, so for this it has to send the packet via the help of intermediate nodes using multi-hop routing scheme. Autonomous terminal. Each node in a network is independent and thus can act both as a host or a router as per the requirements. Dynamic topology. The nodes are free to move arbitrarily with different speeds, thus changing network topology randomly at unpredictable times. Literature review. Out of the various papers studied for the thesis, few have been discussed here. First is Chokri et al., which defines a routing framework to improve energy consumption by isolating the network into groups, and from these groups it tries to find out different routing patterns within and the between the clusters, that is inter and intra-cluster route patterns, and then recognizes the most ideal path in terms of energy. The next one is by Ashkar and Sharma. They proposed an improvement in AODV convention and achieved an energy efficient AODV routing protocol in which upgradation has been performed in route request and route reply packets. Badal and Kushwa, they provided a modified version of DSR protocol, thus resulting in an improvement which provides an energy efficiency and lifetime of the nodes, increasing lifetime of the nodes in the minutes. Here the drawbacks of DSR have been taken into account. What they does is they calculate the total energy consumption in transmitting and receiving the packet, and each node sends its value of total energy consumption along with route request packet, and keeps on updating its value as it receives that packet, and in this way the destination, it follows the route which has the lowest value of the energy total energy consumption value. Next is Kumar and Dubey. Kumar and Dubey proposed a link stability control maximum energy with multipath routing scheme. In this, the algorithm chooses the node with the highest energy among the neighbors, and then builds multiple paths, and from the multiple paths the destination chooses the one which has highest energy, the path which has highest energy among all. Next is Palaniappan and Chalin. They proposed a steady and energy effective routing protocol. In this, the QoS monitoring agents collect the link stability matrices, just as like link expiration time and residual battery power etc., as an input to the fuzzy logic based scheme to provide output of the route selection probability. Next is Shobha Tyagi et al. They have worked on the reliability of data transfer from source to the destination. Next is Dev Raj et al. They proposed ECDSR convention in an attempt to multiply the lifetime of the network where routing is required to be proficient in terms of energy consumption. They are also working on the premise of minimum edge energy. Next is our problem statement. Most of the existing routing protocols, they work on the concept of the shortest path from source to the destination, which they calculate in terms of the minimum hop count, but they are not at all considering the energy efficient routes, which is a very important criteria, because the in minutes the mobile nodes, they have limited battery power with them, and thus efficient use of this battery is required. Otherwise, if the nodes will die, then the whole topology will keep on changing and leading to the reduced network lifetime. The mobile nodes of secondly, the mobile nature of the nodes in ad hoc networks result in link breakage between the nodes. This is one of the factors that leads to packet loss and thus decrease in the throughput. In a study which is done by Tyagi, the authors have worked on the reliability of the data's transfer from source to the destination. For this, they are first arranging the paths in order of the decreasing order of the hop count, and then they calculate the end-to-end delay, then the bandwidth for the shortest path, and at the third point they are considering the mobility of the intermediate nodes. On the basis of these factors, they are selecting the path to be chosen. Now, in the whole criteria, we can notice a few issues. First, they have not at all considered the remaining energy of the intermediate nodes to select the path. Secondly, the authors are using a hierarchical approach. Just like first, they will filter the various options on the basis of the shortest path. After that, they will check for the end-to-end delay, then for the bandwidth, and then in the last step for the speed of the intermediate nodes. But in this whole scenario, it can be argued that there can be some cases that the path is not shortest but still have lesser end-to-end delay and bandwidth. Such kind of paths have been omitted by this approach, and thus amendments need to be made. The objective of my study were to study the various techniques focused on reducing the energy consumption of the network, which was very important, to analyze the performance of the network using reliability based variants of AODV, to design an algorithm to reduce energy consumption and improve reliability in mainnets, to implement the proposed algorithm based on AODV in NS 2.35, to compare the performance of the proposed scheme with reliability based variant of AODV on the basis of energy consumption, throughput, end-to-end delay, and packet delivery ratio. So my proposed work aims at minimizing the energy consumption. For that, the scheme has made use of the location aided routing. For this location aided routing, the assumption has been made that each and every node is equipped in the mobile ad hoc networks is equipped with GPS, and the source node has the knowledge of the coordinates of the destination node. So while forwarding the route request packet, the node will forward the information about the location coordinates of the destination to the neighboring nodes, and the neighboring nodes, which on receiving the coordinates, will make a choice of whether it is located in the quadrant towards the destination or not. If it is not located in the quadrant towards destination, that it will not forward the route request packet. Through this process, all the nodes are not being used for the broadcasting step in AODV protocol. Another thing which my proposed scheme has used is adjustable transmission range of the node. It is well known that if a node forwards the data over a longer distance, it would consume more energy. So the proposed scheme, what it does is, it will check for the residual energy of the node. If the residual energy is less, then it would transmit the packet over a lesser distance. Thus, the transmission range is being adjusted according to the remaining energy of the nodes. So in the end, when the destination receives the route request packet, The destination will then sort out which path to be chosen according to the highest remaining energy, minimum hop count, minimum delay, maximum bandwidth, and minimum speed of the intermediate nodes. This is the algorithm which has been modified and is being used in my thesis. First is the source node S starts forwarding the root request packet to the neighboring nodes. If the destination nodes exist in the routing table, then execute the root reply phase directly. Else, firstly check for the residual energy, adjust the transmission range accordingly, and then find the neighbors. Find the neighbors in this small communication range which has been selected as per the transmission range. Now the neighbors which have been found are put into a set n, and for each node in n, if the neighbors satisfy LAR condition, that is location aided routing condition, only then forward the root request packet until the destination is found. Else do not forward the root request packet. And this ends. Here this algorithm was implemented in NS2, and the first figure 2 shows the broadcasting which is done by the existing scheme which was proposed by Shobha Tyagi, which was just a reliable data transfer from source to the destination. In this, if we can see a network of 50 nodes which have been deployed. Almost every node, all the nodes have been used in broadcasting process from source to the destination, whereas if the proposed scheme is used, then there has been deduction of the nodes which are participating in the broadcasting steps. The black nodes which can be seen in the figure 3 have been exempted from the broadcasting step. Thus the energy consumption has been reduced. Results we are estimating the results on the reliability parameters of packet delivery ratio, throughput, end-to-end delay, and remaining energy. First is packet delivery ratio. It measures the percentage of the packets that are successfully delivered in the network. The formula is given: the number of the packets received divided by the number of packets sent. As it can be seen in the graph, the proposed scheme ERA-AODV, it has a value of 92%, where the existing scheme RA-AODV, it has a value of 82%. Ours has a better value. Next is throughput. In the throughput also, which is defined as the data received at the destination node per unit time. The formula is shown on the slide, and its value is again higher than that of the existing scheme, that is 110 kbps to that of the existing scheme, which is 98 kbps. Next is remaining energy. Remaining energy is the amount of the energy remaining in the network. More is the value, better is the network lifetime. So the remaining energy should be high, which is the main goal of our work. Reduce the energy consumption. Initially 44 joules of energy was average. On an average 44 joules energy was provided to the network, and at the end of the simulation the remaining energy for the proposed scheme was found to be 28.05 joules approximately, and for that of the existing scheme it was 26.29 joules. So ours have done a better work. Next is end-to-end delay, which represents the time taken for the packets to reach from source to the destination over the selected path. This end-to-end delay should be less, and as the graph suggests, the value of ERA-AODV is lesser than that of RA-AODV. In the end, I could conclude that the thesis presents an energy efficient approach that improves the network lifetime and at the same time maintains the reliability of the data transfer. The performance of the network compared on the basis of remaining energy in the network, packet delivery ratio, throughput, end-to-end delay, these all parameters showed an improvement over RAAODP. The credit for the improvement can be attributed to the concepts of location-aided routing and dynamic transmission range that has been used in the proposed scheme. Since the mobile nodes suffer from a number of attacks in future, the security of the network can be worked upon by considering different kinds of attacks. Publication: the paper has been published in an international conference of smart innovations, Springer's International Conference of Smart Innovations in Communication and Computations. These are the references of the papers that have been discussed in this in the previous slide. Thank you.